All right, so we're going to start off here talking about surface area of pyramids and cones by just going over some vocabulary. So in this picture here, you've got a base down here, which is the only non-triangular face. If all the faces are triangles, well then you could choose any of the faces to be your base. However, we'll start talking about regular pyramids in just a second, and then that might influence your decision. So as you have the base down here, you have base edges along the base, and then you have the lateral faces being these triangles that go up to the vertex point. So here's one triangle face, that's a lateral face. Here's another lateral face, and then these edges going up are lateral edges. So just remember some vocabulary. Now, we're not going to be talking about just any pyramids. Usually we're going to be talking about regular pyramids, and I'll describe why in a second. But a regular pyramid has two things. One is the base is a regular polygon. So that would be an equilateral triangle, a square, a regular pentagon, a regular hexagon, and so on and so forth. And then also, it's a right pyramid. So the vertex is directly above the center of the base. That makes it a regular pyramid. Now, we could talk about just any pyramid, and a lot of these formulas would, in some fashion, still work. The problem is, if you talk about how do we find the surface area of an oblique pyramid, or a pyramid where every single of the lateral faces is different, then you're going to at least have to label in here the slant height being different, or the height of every single different pyramid. Because if it's off to the center, if I have my tip over here, then the lateral height, or the height of that lateral cone here, that lateral face here, the height of that pyramid is going to be much shorter than this longer one over here. And so I'm going to have to label a height of 4 different things. I'm going to have to be like, oh, this height's 7, this one's 8, this one's 4, this one's that one, and you have all these lines going every direction. So instead of labeling the height of every single separate triangle, we just say, you know what, let's deal with the case where all of the lateral faces are the same. And that's the last thing here, which is if it's a regular pyramid, then all of the lateral faces are congruent triangles. They're isosceles, but we know that they're all the same. So all we need is a single slant height, or single height of one of those triangles. And then we go 1/2 base times height to get the area of that triangle. And then once we have the area of a single triangle here, we just multiply it by 4 because there's 4 triangular faces. So that's the main reason we'll talk about regular pyramids. Is not because you're not capable of finding the area of triangles. It's just for the simplicity of showing you an image and not having lines going, the height of this triangle is, and the height of this triangle, and the height of this one. We said, let's deal with the case where all the triangular faces have the same height. Okay? All right. So that being said, let's talk about this slant height, okay? Now, this is probably the single most common mistake when people are dealing with triangles, is mixing up the height of the pyramid and the height of the triangular lateral face. So the height of the pyramid is, if I set this pyramid flat on the ground, how far is the tip above the ground? That's perpendicular or orthogonal to the base. Orthogonal is a nice word. It just means perpendicular in all directions, right? Not just perpendicular in that direction, but perpendicular here, perpendicular here, perpendicular here. That's what orthogonal means. But anyways, so we've got this height inside the pyramid from the tip straight down through the mountain to the sea level at the bottom. That's the height of the pyramid. We're going to use that when we find the volume of the pyramid. However, if we want to find the area of this, just a triangle on the surface, then what we need here is we need to know what's the height of this triangle on the side. So the height of this triangle on the side would be a line that we would paint on this surface triangle that would go down the middle of it and be perpendicular to the base of this triangle. But it would be like a Sharpie or a paintbrush on the surface, on the outside of your triangle, outside of your pyramid. The height of the pyramid inside bored straight down through it to get to the bottom center. Okay, and that's the most common mistake. The height of the pyramid and the slant height are very different. This one's inside, This one's outside. We use this one for volume. We use this one for surface area. Okay, so just make sure you understand the differences between those. Now, as we move forward, I just want to say one hint is it's very common that they'll give you one height and not the other. So either the height of the pyramid or the slant height, and you'll have to convert between them. So it's really common that we use the Pythagorean theorem. So here's a picture. The problem says find the area of each lateral face, but the main thing is if I want to find the area of each lateral face. So this is a regular pyramid, which means each one of these is an isosceles triangle. They're all congruent, so we have 4 congruent isosceles triangles. If I draw one at the moment right now, I know the base, since it's a square, it's a regular pyramid, I know each one of these is 40. I know there's right angles at every corner. So I go, okay, so I know this is a 40 feet on the bottom of this triangle. But shoot, all I know is it's isosceles. I don't have any other information. So that's not enough. I don't know if this is a really tall isosceles triangle, really short. I don't have enough information yet. So going back here, I need to use the height. Now notice that this height goes straight down to the center of my base. I need to use that to find the slant height. So the slant height would be on the surface of my triangle, connected to the middle of the side, so it splits it into 20 and 20. And if I connect these, since I have perpendicular to the ground, I know my slant height here, and my actual height of 21, I could use the Pythagorean theorem here, because this is half the base, so I have 20 here, and if I went all the way across, this would be another 20. So I could use Pythagorean theorem here to say, okay, well, 20 squared plus 21 squared equals L squared. So that's 400 plus, what is that, 441, I think. So I get 841 is L squared. So I get L is the square root of 841, which I don't believe works out nicely, because that'd be somewhere between, let me see. Yeah, no, that couldn't work out. Does it? Let me see. Square root of 841. Oh my gosh, it is. It's 29 exactly. So L is 29. So what that tells us is if we take this triangular face here, right, and stand it two-dimensionally just on this paper, we get that the slant height, or the height of this right here, this lateral face, this triangle that I took off of the pyramid and laid flat, that height is 29. And so the area of this is just 1/2 base times height. So we get 1/2 40 times 29. So that's 1/2 40, oops, I got to use x, times 29. So that's 580. So we get the area of each triangle is 580 per triangle. And so that'd be 580 here, 580 here, 580 here, 580 here. So it says find the area of each lateral face. And so lateral faces mean only the sides, not the base. So the area of each is 580 for each of the 4. Okay, just wanted to show you it's really common to use the Pythagorean theorem to go between height and slant height. It's a really common trick. Okay, so how we actually get a formula for the surface area. Now, this has to be a regular pyramid. But what we do is we essentially just open this up. We flap down each one of the triangles. And as we flap this down, what we get is this shape over here. Okay, and this shape over here can be broken up into a base, right? We'll have to find the area of the base. And then we'll add up some number of triangles. Now, really, this 6 just happens to be the number of sides of the base, right? And then each one is just a triangle, so 1/2 base times height. But here's the thing. If we write that out, so number of sides of the base shape times the area of a triangle, or number of sides times 1/2, and this B is a single side length, so single side length of the regular base shape, right? So a regular base shape. Well, think about this. I could then rearrange this to just say, okay, well, that's 1/2 times number of sides times B. So if I have a regular shape and I have one side length times the number of sides, that's just the perimeter of the base. So our formula becomes one single base, right? This is analogous to in a prism. It used to be there were two bases, and we add up perimeter times height because this was a rectangle, so base times height. So now analogously, for a pyramid, we just have that, well, there's not two bases, there's one base, and then we add up because it's a triangle, it's 1/2 base times height. So really similar, analogous in the layout. Make sure you understand the key here. B stands for the area of the base polygon, whatever shape it is, pentagon, hexagon, so on. P stands for the perimeter of the base polygon, again, whatever shape it is. And L stands for the slant height. I made sure to circle, underline slant height, not the height of the pyramid. Okay, and then one other thing, any problem for sure could just ask for, find the lateral area, not the entire area, but just the lateral around the side area, ignoring the base. And it's totally okay if that comes up. The lateral area is just ignore the base, and the rest of it, the 1/2 PL, would be the lateral area. Okay. Now, this is cool. Now, a cone, now there's all sorts of ways to unwrap this, prove this. I just like saying all a circle is a regular polygon with an infinite number of sides, right? If you go, okay, I have a regular decagon. Now I've got a regular 100gon. Now I've got a regular 1000gon. All the same formulas still work. 1/2 AP. We've got, however you want to cut it up, we've got all the same formulas work for it. And so if we cut this up into, and I mean, you can even think about literally slice this up into infinitely many triangles that are infinitely thin and open it up into like a sunburst with these infinitely thin triangles. And then we just lay those out. We still get, though, the same exact formula where we take the area of a base, the base shape happens to be a circle, and then we add up, and the area of the lateral face is still just 1/2 the perimeter. Like, and this is the way you do it. If you took all of these triangles and then you laid them out, okay? So you've got all these triangles laid out. Well, they all have the same height, right? That height, when they unfolded, that height was the slant height. And then what do we get when we add up the bases of all these? Well, the bases of these, that's just the perimeter of this circle. So that's just the circumference or the perimeter of the circle. Now we could just slide the tops of all these triangles together, because we know if we take a triangle that has base times height and we move the tip parallel to the bottom, left and right, it's still 1/2 base times height. Doesn't matter if the tip is over here or if the tip is over here, same area. So I'm going to slide all the tips together here until that forms a single triangle where the base length is the circumference, the height is the slant height, and so we get 1/2 the circumference times the slant height is the area of all this sunburst part, and then plus the base. And that's exactly what we get. We get the base plus 1/2 CL. Okay? Now really this is the exact same as if it was a pyramid. All we did was essentially say, well, let's get rid of the perimeter because it's a circle. Let's call it circumference. And that's it. Same formula otherwise. So again, I view a regular cone, aka a right cone, because a circle is in a sense regular, although we don't call it that. But a regular cone or a right cone, we say is essentially just a regular pyramid with infinite sides on the bottom. So we could use the formulas for a pyramid. We just say, yeah, it's base plus 1/2 perimeter times slant height. And all I did was just say, well, okay, technically we call the perimeter the circumference. Otherwise, it's the same formula. This is still lateral area. Okay. So that being said, let's just do a bunch of practice problems. That's the lesson. Here's the first one. Okay, so find the surface area. So it's asking for the whole thing of the regular pyramid. I see that it's implying, because the slant height is giving you this side, that this is 8 and this is 8, and that this bottom side is the base. So the base shape here is a regular polygon with 3 sides, so it's an equilateral triangle of 5, 5, 5. So my formula says I need the surface area to be the area of the base plus 1/2 perimeter slant height. Well, I don't have the area of my base yet, but 1/2. Well, perimeter of my base is obviously 5 plus 5 plus 5 is 15. Just adding up these sides over here as a perimeter of my base. And then the slant height is given in my picture. The slant height is 8. So times 8. So all I need to do is find the area of this base, and then I add it to 1/2 and that. That's 4 times 15. So I get the area of my base plus 60. So the lateral area here, right? Remember the lateral area happens to be 60. We already found that. It gave us all the information we needed. But now we just need to find what is the area of the base. Okay? And this is something we've done a lot in the last unit. The way we deal with any isosceles triangles, we cut it down the line of symmetry. And what that does is that splits the bottom into 2.5, 2.5. In an equilateral triangle where all the angles were 60, it also splits the top angle into 30 and 30. So you could do this in a variety of ways. Personally, I like 30, 60, 90 triangles. You could use Pythagorean Theorem or trig if you want. So I'm going to say this is similar to, with a 60 and a 30, it's similar to a 1, 2, root 3. Making sure with my 60, the root 3 is opposite. Opposite of my 30 is my 1. And I notice that this is exactly times 2.5 bigger. So this side here is 2.5 root 3. So the area of my base, 1/2 base times height, is 1/2. The entire base of the triangle is 5. And the entire height we just calculated is 2.5 root 3. So over here I get, this is, oh, it's not going to work out nicely. If I just multiply these numbers together, I get 1/2 times 5 times 2.5. I get exactly, not approximately, exactly, ooh, I missed a decimal there. Well, I get 6.25 if you just move a decimal place over 1 in there. So 6.25 square root of 3. So this is the exact answer. You could have had this as 25/4 root 3, either one exactly the same. And this can't simplify anymore. You could punch that into a calculator and approximate it if you want. But the hard part of this problem was finding the area of the base. Other than that, it was just plugging it into the formula. Okay, so let's describe and correct the error in finding the surface area. Okay, so let's see. Surface area of this, here's the base. The base is a square. Well, they said there's one base plus 1/2 perimeter slant height. That's correct. The area of the base is a square, so 6 is a side length, so 6 squared. That's correct. Plus 1/2. The perimeter of base, 6 plus 6 plus 6 plus 6 is 24. And then times 4. Oh, there's the mistake. By far, most common mistake I see with pyramids. This is the height of the pyramid, which is very different than the slant height of 5. So the mistake here is they should have plugged in a 5 here, because that's the slant height, having to do with the surface triangle, having to do with the surface area. We'll use the height of the pyramid when we get to volume, and we'll be doing the volume formulas using that. Okay, and then just replace that with a 5 and redo the arithmetic. But the main explanation is they chose the height of the pyramid instead of the slant height. Okay, so this one, and I circled this in pink because this is what's important. Find the lateral area of the right cone and round it to 2 decimal places. Okay, so first I'm going to write the formula here. Now, yes, I could have technically used C for circumference. I just remember one formula, right? One base plus 1/2 perimeter slant height, and that's for all pyramids and cones, or at least all regular pyramids and right cones. All right, let's get a drink of water. So if I want the lateral area, I'm only looking at this. I'm going to not include the base, okay? Because lateral comes from the Greek word or Latin word for sides. And so what it means is, what's this whole side area and not the bottom? Okay, So that being said, let's look. We've got 1/2 the perimeter of a circle, because this is a circular base down here, is 2 pi r, and then times the slant height. So the 1/2 and the 2 cancel. So we really got the lateral area here is pi r l. We're given r, so this is nice. So the lateral area is pi times 7.5 times, we don't have the slant height. So let's go ahead and find the slant height. Well, we know the height of our cone is 25. Okay, and this would go back here, the bottom back side. And we know the radius here is 7.5. If we want to know the slant height, we know the height is perpendicular to the base. And so we're going to use the Pythagorean Theorem here. We're going to say 7.5 squared plus 25 squared equals L squared. So this is 7.5 squared plus 25 squared, 681.25 equals L squared. So square rooting both sides, we get this is equal to 26.100, or approximately 26.100. Now, I would keep more decimal places in general because it said round to 2 decimal places. Just so happens my multitasking only goes to 3 decimal places. But I would have 4 or 5 here in the middle of a problem if I'm going to end with 2 decimal places. So I've got my lateral area is around, because now I'm dealing with approximations, pi times 7.5 times 26.100, and that decimal keeps going. So I'm going to take that, and I'm going to go times 7.5 and times pi, and I get 614.98. 614.98. And now that might be a little different if you use 3.14 for pi, or if you used more decimal places, but that's a good approximation. Okay, find the entire surface area of the right cone. So this is a very similar problem. Again, I can identify right away we're missing the slant height. So we're going to have to use 5 squared plus 8 squared to get the slant height. So that's 25 and 64, or 89. So L is the square root of 89. Okay, so right away I got my slant height. And I know my entire surface area is the area of the base plus 1/2 circumference or perimeter times slant height. So in blue here, I get pi r squared, or pi 5 squared, plus, and up here it was 1/2 2 pi r times L. The 1/2 and the 2 cancel. So I get pi times r, which is 5, times L, which is square root of 89. So I get 25 pi plus 5 pi square root of 89. And you can absolutely approximate that, but I like to leave it as an exact answer. So there's my exact answer. I know it says answer in 2 decimal places, and you can plug that into a calculator. Okay, so the last 3 are composite figures. And I wanted to practice this a little bit because you don't just say surface area of cone plus surface area of cylinder. Okay, so let's look at this. Find the surface area of the solid, okay? So all the pyramids are regular, the cones are right. Great. Okay, so look at this. Of the cone on top, what do I have? I have the lateral area, but no base, right? The base is not exposed to the exterior. And I have the lateral area of the cylinder, and then I also have one base of the cylinder. I have the bottom. So those are the 3 things I want to add together. There's no top. The main things that are missing here is you're missing the bottom of the cone and you're missing the top of the cylinder, because when you attach the cone to the cylinder, those 2 get covered. So we're not including those. So you could just say surface area of cylinder plus surface area of cone minus 2 circles. You could do that. Okay, so I'm going to break this up, and I'm going to say, okay, so my total surface area is, I've got a base plus, they both have the same base, so I'm not going to clarify, plus I have the lateral area of the cylinder plus the lateral area of the cone. So I've got pi r squared plus the lateral area of the cylinder is the perimeter times height, and the lateral area of the cone is 1/2 perimeter times slant height. So now I've got pi r squared plus 2 pi r h plus 1/2 2 pi r L. So let's start plugging things in. I know the radius of all my circles is 5, so I get pi 5 squared plus, now I'm still talking about, and this is important, I'm still talking about the cylinder. So in my cylinder, my height is 12. This is h of the cylinder. Okay, so I'm going to go back down here. I've got plus 2 pi, my radius is still 5, times the height of my cylinder, which is 12, okay? So again, that will give me the lateral area of my cylinder. All right, then I say, okay, over here I've got 1/2 2 pi 5, right? The radius of all these is 5, and then I go, oh shoot, I need the slant height yet again. So off to the side, I need to find the slant height of my cone. So I've got that the height of the cone is 4, which is perpendicular to the radius of the circle, which is 5, and I can see that down at the bottom. So this is a 5 here, and a 4 here. So Pythagorean Theorem can get me this missing side. So I've got, well, I don't really have room down there, but I've got 4 squared plus 5 squared equals c squared. That's 16 and 25, or 41. So I've got a slant height of square root of 41. All right, and then I can just simplify this a little bit. So this is 25 pi plus, let's see, 2 times 5 is 10, so that's 120 pi plus 1/2 and 2 cancel. I get 5 pi root 41. Now I can't combine this with anything because that odd square root of 41, but I could put together these two because they're just counting up how many pi's I have. I have 145 pi plus 5 pi root 41. Great. Okay, again, you could approximate it. I'm just going to leave it exact. Okay, this one, very similar. In fact, it's basically the exact same problem, except instead of circular, it's square. So what I've got here is I've got a top, right? So just the lateral area, no base. And now I've got the lateral area of this, no bases. And then on the bottom I've got a square, right? So 1 base. So it's exactly analogous. I'm going to say the surface area is that bottom plus the lateral area of the prism plus the lateral area of the pyramid. Okay, so I'm going to say, well, the base is a square, so it's 5 by 5. So I'm going to say the base is 5 squared plus the lateral area of the prism is perimeter times height, just like in the last one. The lateral area of a pyramid is 1/2 perimeter times slant height. So I get 5 squared plus perimeter of the base is 5, 5, 5, 5. There's 20 is the distance around the base. The height of the prism is base to base. That's 5 plus 1/2. Now, the same base is on the pyramid as on the prism. So I get the perimeter of that square is 5 plus 5 plus 5 plus 5, or 20. And then times, and yet again, they didn't give us a slant height. So what I got to do here is I'm going to, in pink, say, well, I know this height here is 3. And I know the distance to the side here is half of the square, or 2.5. What I need to find is what is my slant height. So my slant height here, and I can do it right over here on the side. So 3 squared plus 2.5 squared equals L squared. So that's, oh dang. Let's go 3 squared plus 2.5 squared. So I get 15.25. So square root of 15.25. Down here, square root of 15.25. All right, so what I get here is that going to work out nicely if I square root that? No, it's not. Okay, I was just wondering. So just simplifying this, we get, going back to blue here, we get 25 plus 100 plus 1/2 of 20 is 10 root 15.25. And so this can be combined, although not with the funky square root. So we get 125 plus 10 root 15.25. Now this is an exact answer, but you could approximate that if you want. All right, so last problem we'll do together here. I think the bell's going to ring, but if it does, we can just ignore it for a minute or two. Okay, so what we've got here is we've got the lateral area of the top cylinder, or I mean cone, right? We got all around the side. We got no base. And then we got the lateral area of the bottom one. And again, no base. Right? There's no bottom to the top cone, and there's no top to the bottom cone. It's just the lateral area and the lateral area. Two different cones, but just their lateral area. So the total surface area is lateral area of the top plus lateral area of the bottom. So we get for both of those 1/2 PL plus 1/2. And again, you could use circumference more correctly. I just remember it as perimeter is easier, one formula. Okay, so 1/2, and the radius for both is, so 2 pi r L plus 1/2 2 pi r L. Now, of course, the 1/2 and the 2 cancel in both of these, so I get pi times a radius of 3 times a slant height, and then plus pi times a radius of 3 times a different slant height. So let's see what we get for slant heights. On the top one, we get a 3, 4, 5 triangle. So this is a 5 slant height. And for the bottom one, we have this is a 3 radius and an 8. And so we need to find the slant height. So 3 squared plus 8 squared is L squared. That's 9 plus 64, or 73 is L squared. So we get L is root 73. So this is root 73. So this is your exact answer. 15 pi plus 3 pi root 73. Again, you can approximate that if you want, but that's your exact answer. So that's how you kind of take it apart and deal with lateral area and base area totally separately. I hope that was helpful. Yeah, good luck.